From the studios of Boise State Public Radio News, I'm Samantha Wright, filling in for Gemma Goddard. It's Idaho Matters. You may remember the small volcanic eruption in Iceland 3 years ago. When the lava began burping its way out of a fissure, it created a few new craters, while hot, molten rock flowed around the rugged landscape. Those craters caught the eye of Ian Flynn, who noticed it looked a little like a crater on the surface of Mars. And as he looked closer, he found it looks just like a crater on Mars. Flynn was working at the University of Idaho at the time. He realized that the similarity of these spatter cones meant Mars at one time had volcanoes like those found on Earth. And to find out more and what it means for the red planet and our planet, Flynn joins us now. He's a research assistant professor at the University of Pittsburgh. Ian, thanks for coming on Idaho Matters today.
Thanks for having me.
Okay, so first off, what is a spatter cone? Not splatter, spatter cone. What is that?
Well, they do kind of splatter in a way as well, but I'll explain. So when you think of a volcanic eruption, most of us think of kind of lava flows coming out of a hole in the ground or erupting tall ash clouds that go up into the atmosphere. Spatter cone, or the process that forms them, is kind of the middle between those two, where you have some lava coming out of an opening, but there's enough gas and dissolved volatiles in the magma that when they come to the surface, they kind of burp, get airborne, and then fall back to the ground in kind of a nice ballistic arc pathway, and then they splatter on the ground, and that kind of keeps happening over and over again, and they build up on top of each other to form what we call a spatter cone.
That is really cool. And you're describing, I think, very specific conditions that have to happen for this to happen this way.
You are correct. So spatter cones, or the eruptions that form them, only occur when you have enough volatiles in the magma to, again, launch magma particles into the air, and then to have them land on the ground and form this specific spatter feature, they need a specific cooling rate. So from an environmental standpoint, if you think about how hot or cold it is outside and how quickly the magma cools once it lands, it's a very narrow range of parameters that supports this spatter feature from forming. If they cool too quickly, you get what's called a scoria cone. So that's a very fine grained particle that almost kind of a bit bigger than sand, but it's loose and unconsolidated. If it doesn't cool fast enough, it'll just land and form a lava flow. So right in the middle is spatter, where it cools a little bit, but not enough to form the scoria. So you get this rough and knobby texture, which is the spatter cone.
Okay, so you found this happening in this volcano in Iceland, and then you found what looks like one of these spatter cones on Mars, and you sort of put them together. Tell me about that.
So we've known, Mars is a volcanic planet. Majority of the surface is covered in some type of volcanic feature, whether it's, volcanic constructs, Olympus Mons, Osea Mons, or lava flows that are on the flanks surrounding area, or large volcanic fields and plains. And the theory of Martian volcanism back in the 70s and 90s, when we first started really investigating the planet, said spatter cones should form on the surface. We should see these. But in our 50-ish plus years of exploring the planet, it's never really been a positive identification or a detailed investigation to look for these. So part of Dr. Eric Havada, who is working with the University of Idaho's expertise, are these spatter features on Earth. So I said, let's go take a deep dive on Mars, see if we can find them with the new generation of high-resolution imaging instruments we have orbiting the planet. So luckily we found one. I'm like, this looks remarkably like features I see on Earth that are spatter cones. Dr. Havada agreed. So then it was just to find a good analog for this particular one we were seeing on Mars, and that happened to be the 2021 Fagradalsfjall eruption in Iceland.
Okay, so I'm looking at a picture. We're going to put it on our website. It's the Mars cone and the one in Iceland you're talking about, and you put them side by side. It's like a perfect match. I mean, they look just like they're the same.
That was my exact same thoughts when I found the Iceland one, looking at, we see spatter cones all across Earth. Idaho has a bunch of them in craters of the moon and other locations. But those had been heavily weathered, They're older. Earth has a much more rapid erosional environment than Mars does. So older features kind of start to degrade, fall apart. You get vegetation. This Iceland one, only being 3 years old approximately, hadn't been weathered that much. So it was very easy to kind of have this visual comparison of, wow, that's a fresh cone and it looks almost identical to what we have on Mars.
Wow. We're speaking with Ian Flynn, a research assistant professor at the University of Pittsburgh, about volcanoes on Mars. So is this a big deal to figure out that Mars has these? Does this fill in some kind of gap in Mars's history?
So it does. It does a couple things for the Mars volcanology community. One, it fills what you could call it an observational gap. The theory said we should have these features on Mars. We hadn't really found concrete evidence for one. Now we have. So that fills in kind of the Mars volcanology database, you will, of what does this feature look like on Mars. We can now check that box being, hey, we found one. We know what it looks like. Hopefully now we can use these criteria to go find others. It also helps us understand something about the Mars environment at the time this feature was in place. Because they take a very narrow range of eruption, magmatic, and then environmental emplacement conditions to form, it tells us something about the Mars environment at that time, specifically how warm or cold the atmosphere was. Because if it was too warm, these erupted spatter fragments might just turn back into a lava flow, and you would get a different feature, more like a small eruptive cone, kind of like what we see in Hawaii. And if it was too cold, the erupting magma would cool very quickly, and we'd get what's called a scoria cone, which we do see on Mars quite frequently. We just haven't found previously these spatter cones. So yeah, it gives us a very narrow range of environmental conditions and eruptive conditions for these features to form. So it helps constrain the history of Mars volcanism.
So your research paper sort of hints that there might be these kind of spatter cones on places like Venus or even our own moon, correct?
That is the next direction the work is planning to go to. Specifically, Venus will be the priority of it. The environment on Venus is so extreme with the incredibly dense atmosphere. We think, again, theory should state that you could have explosive volcanism that forms spatter cones on Venus, but we haven't found any yet, partially because we haven't had a mission there recently. NASA, however, has selected 2 missions, Veritas and Da Vinci, to go to Venus in the upcoming years. The European Space Agency has selected Envision to go explore Venus as well. So with the upcoming new missions, there is potential for us to extrapolate this work to Venus.
Wow. So how exciting was it to actually look at these 2 pictures side by side and say, well, I think that's a spatter cone on Mars? I mean, were you very excited?
Oh, incredibly excited. I'm at heart a nerd who loves visual comparisons of data just very simply and being able to show people things that are very straightforward. Science can be overly complicated. Scientists don't always do a good job conveying, the study. And having 2 features like this that just visually look so similar, but be on 2 different planets I nerded out. I was like, this is so exciting that these just look so similar. Now let's figure out what that means scientifically. So yeah, this was a very incredible find.
Well, it's fantastic. We've been speaking with Ian Flynn, research assistant professor at the University of Pittsburgh, about volcanoes on Mars. We're going to put that picture of the 2 volcanoes side by side on our website, boisestatepublicradio.org. Ian, thank you so much, and good luck in your future research.
Thank you so much for having me.
Thanks for listening to Idaho Matters. Boise State Public Radio and Idaho Matters are members of the NPR network. It's an independent coalition of public media podcasters. You can find more shows in the network wherever you get your podcasts. I'm Samantha Wright. We'll see you tomorrow.
No matter what happens in Washington, the NPR Politics Podcast is here for you. For the latest news, insights, and analysis from the election and beyond, listen to the NPR Politics Podcast.